So at the top where it says 9.7, law of sines, law of cosines, you can write for non-right triangles. So this will be for obtuse triangles, it'll be for acute triangles, and things like that. Okay? We're going to learn law of sines today, and then we'll learn law of cosine tomorrow. What you're going to find is the law of cosine is usually the first step, and then you'll just do the law of sine again. So law of sine, super important. Law of cosine, more or less important. Before we do, we're going to talk about finding area of triangles. So far, you've used trig ratios to solve right triangles. In this lesson, you'll need to learn how to solve any triangle. When the triangle is obtuse, you can still find a trig ratio. You just type these into your calculator. We're going to round to 4 decimal places. So tangent of 150. Go ahead and type it into your calculator. This is a beautiful warm-up because we know how to do this. You can get a negative, and a lot of them you will. So we're rounding to 4 decimal places. What did we get? 0.5774? Negative 0.5774. We all agree? So because it's obtuse, that's where that negative comes in. You'll see how it plays a role in a minute. Sine of 120. 0.866. Negative 0.8 or just 0.8? 0.866. That's a 0 if you want. And then cosine of 95. Negative 0.0872. Good. Did everyone get those? Beautiful. We're going to use this to find the area of a triangle. What is normally the formula for the area of a triangle? 1/2 base times height. So in this section, you won't be given the base and the height. You're going to be given something else, and you'll have to plug it in. The 1/2 will remain. You'll see it here in a second. All right, so I'm going to show you what it looks like. Don't write anything down yet until I tell you, because I'm going to simplify it for you. You could find the area of this triangle by doing 1/2 times the length of B times the length of C times sine of angle A. So I'll highlight it. Don't write it down because I'm going to shorten it for you here in a second. So we would know B, we would know C, and we would know angle A. So everyone sees B, C, angle A. Option 2, you would do 1/2 times the length of A, which is here, times the length of C, which is here, sine of angle B. And then last you could do area is 1/2 times the length of A times the length of B times sine of C. So hopefully you saw a pattern there, because it's going to be 1/2 times the side times the side times sine of an angle. So 1/2 times the side times the side times sine, and it's the included angle. So when we're finding the area, 1/2 times the side times the side times sine of an included angle. This section is hard sometimes because side sounds a lot like sine. So you're going to hear me be obnoxious so that you can know which one I'm saying. We're going to practice this. Find the area of a triangle. So we don't know the height, which is why we can't use the formula like normal. So we're going to do 1/2 times the side times the side times the angle. So what are the two sides that we're given? 17 and 19. And then times the sine of the included angle. It does matter that you have the word sine. Has to be there. You have a beautiful scientific calculator. You can literally type the entire thing in. 1/2 times 17 times 19 times sine of 135. We are rounding to the nearest tenth, like the directions say. What do we get? 114.2. And then it is area. So we'd say units squared or squared units. In this section, a lot of people are like, do I need to show work? On your quizzes and tests, if you don't write like what you plugged in, I can't give you any credit. I usually give you credit for knowing the formula, for plugging in, and then telling you the correct answer. So that's 3 points. You'd be missing out on some if you don't write anything down. But also if you type something in wrong, then I really can't give you any credit because then all of it would be wrong. So I do recommend writing out and then plugging it in. All right, so we're going to talk about law of sine. Okay? The law of sine. I very much enjoy it. You're going to end up setting up a proportion and then solving the proportion using sine. So the trig ratios in the previous sections can only be used for right triangles. You'll learn 2 laws that you can use to solve any triangle, including right. You can use the law of sines if you know any 2 angles and a side. So go ahead and write next to it. You will use this for angle, angle, side, or angle, side, angle. You could highlight it if you want. You have this as well. So if you know angle, angle, side, or angle, side, angle, or when you know like the bad word, side, side, angle can't be used to prove triangles are congruent. It's just a case where you know 2 sides and an angle. So here's how to kind of abbreviate that. Do you have a known pair? This is the word or the wording you're going to hear me say a lot, a known pair. So here's what I mean by a known pair. A known pair is when you have a side and the angle that it is paired with. So if we knew this was 42 degrees and we knew this was 3, that is a known pair. Use the law of sine. That's literally the only way to say a known pair. But again, if angle C was 70 degrees and you knew that this side was 24, you're looking for a side and the angle it's across from to use the law of sine. Okay, a side and an angle is a known pair. All right, so a corresponding angle and side, we're going to set it proportional to another corresponding angle and side. So you have a big blank section. We're going to fill it in. You're going to set up 2 fractions. This is option 1. You would have sine of angle A over side A. Go ahead and write that in first. So sine of angle A over side A. Remembering that capital letters represent angles, and then lowercase letters represent sides. So we would know sine of angle A over side A. And you could set it equal to sine of angle B over side B. So you're going to set that equal. You could also set it equal to sine of angle C over side C. So obviously in a proportion, how many fractions do you have? In any proportion, fractions. You have two. So we could have this equal to this. You could have these 2 equal. You could have these 2 equal. I'm just showing you kind of the pattern. If you look, all of the angles are on top. Sine of angle A, sine of angle B, blah, blah. And then all the sides are on the bottom. This is option 1. I'll tell you the difference between the 2 in a second. Option 2, you could also set up where the sides are on the top. And sine of angle A would be on the bottom. So this is like an OR. So you could set up a proportion where a side is on the top, sine of angle A is on the bottom, side B is on the top, sine of angle B is on the bottom, and then side C over sine of C. So students ask, how do I know? How do I know which one to set up? Let's go back for a second and look. If I set up a trig ratio, do I want x on the top or on the bottom? I want it on the top, right? It's the same situation. Whatever is missing should be in your numerator. So you're going to see when we set up, if we're missing an angle, we're going to set up like this, where my angle is in the top. If we're missing a side, we're going to set up like this, where my side is in the top. So that's going to show you the difference between the 2. Okay? So our first example, we're going to solve the triangle. This means find everything. All missing sides, all missing angles. We're going to round to the nearest tenth. So, do we have a known pair where we know an angle and the side across from it? Yes, we have a known pair and it's A. Okay? So what we're going to end up doing is using this pair with another to solve for something. So we have 11, and that's the only other information we have, correct? So what is across from 11? B, angle B. So we're actually going to find angle B first. We can't find C first because we have no information about the angle or the side. We would set up and have nothing to do with it. So we have to find angle B first. So we're missing an angle. So we're going to say sine of B. We're going to put that in the numerator. Over side B, I'm going to write the proportion first, and then we'll plug in. And it will equal, remember our known pair, we know angle A, so sine of angle A over side A. So remember, this is our known pair, where we know the angle and the side. So we're going to plug in sine from angle B, we don't know B, over, what is side B? 11. Equals sine from angle A, what is angle A? 115 over 20. So now we have a proportion. We want to solve for B. It's attached to sine, so we need to get sine of B alone first. That's being divided by 11. So you're going to multiply times 11 like normal. So both sides, I don't have any room over here. Multiply both sides by 11. Here's where you want to be picky with your calculator. You're going to type in all of that on the right side, and do not clear your calculator. So don't hit clear. Leave it be, because I'm going to use the answer button. So type in sine of 115 over 20. You're typing in all of this, all at once. Sine of 115 over 20. And then hit next, so the 11 is to the side. What? You have to close the parentheses always, yeah. She said, do you need to close parentheses? Yes. If you have sine or cosine or tangent or whatever inside of a fraction, it has to be closed. So we all have sine of 115 over 20 times 11, yes? All right, so let's look at the fraction that we get. Times 11. So I got 0.49846928929. Did you type in sine of 115? Okay. Did everyone else get it? 0.4, all that stuff. So don't hit clear. I'm going to write it down. You don't have to write it down. Obviously I'm recording. I don't know if you know that. So this is what sine of B equals. Have we solved for angle B yet? No. Would it make sense for angle B to be less than 1 degree? No. So this is what sine of B is equal to trig ratio-wise. We want to solve for B. How do I get angle B by itself and get rid of sine? I've got to use the inverse, the shift button. So here's what you need to type. This is why I said do not clear your calculator. Hit shift sine. So shift sine of previous answer. Your previous answer was that long decimal. Answer is next to the equals button if you have a Casio. And then you hit enter. So shift sine of previous answer. I would not round. I would not round the middle of the problem. I would not have typed in anything except for 0.4984692829. Do you want to be exact in the middle of a problem? But anyways, so you hit shift sine of previous answer. What do we get for angle B? 29.9, because it says 10. So the measure of angle B is 29.9 degrees. Okay, it does say solve the triangle, but we know angle B is 29.9. All right, so how can I find the measure of angle C? Add and subtract from 180. So we're going to add 115 to that, and do 180 minus. So you should get 35.1 degrees. How are we doing? Did everyone get 31.1? Okay. The last thing we need to find is the length of AB, or C as they call it. Okay, so now for C, we know 35.1, so we're able to set up a law of sine. What I'm missing is a side, though, so we're going to put side C on the top. Sine of C on the bottom. And then I would use the same known pair as the beginning, except for this time, side A will be on top, and sine of angle A will be on the bottom. So we're just using the same known pair and going from there. All right, so we don't know side C, so we're just put a C there. We do know sine of angle C. Angle C is 35.1. What is side A? Still 20. Over sine of angle A, which is 115. You'll like this one a lot better because C is, being divided by sine of 35.1, so we're just going to multiply. Once you have multiplied, you'll have C by itself, and you'll just type it in your calculator, and you'll have your answer. So, take a moment. Did you get 12.7? Perfect. So in this case, you could call it C. It did call it C in the beginning. So if it doesn't, you would say the length of AB. Here's what I'll point out to you. The biggest side should be across from the biggest angle, and so on and so forth. So what was my biggest angle? 115. My biggest side is 20. What's my smallest angle? 29, and it's across from 11, which is my shortest side. It should always be like that, and the medium side's across from the medium angle. Do you have any questions over this problem? Yes, go for it. So 20 and a fraction. So a lot of people's question is, how do I know where to start? Usually at the beginning of learning this, I just have you solve for one thing at a time instead of all of it. But you want to start with your known pair, and then something you know and something you do not know. So you only want one missing thing in any equation. We couldn't have used C at the beginning because we didn't know side or angle. We knew nothing. Okay, but we're going to see another case here. Go to the next one. So again, the first thing you want to do is locate a known pair. An angle and a side where we know both. So A, B, or C, which one is the known pair? B, because you know 25 and you know 15. You want to solve for what we do not know. So we're missing an angle and two sides. These are the ones that people like the most because we can very easily find angle A, right? Because you know two angles in a triangle. So let's go ahead and find the third. Add them up. Subtract from 180. What do we get? 48. So from here, it doesn't really matter where to go. When it comes to law of cosine, you usually solve the obtuse angle pair first. So if you want to be in like that habit, we can do the obtuse first. It doesn't technically matter here. It will matter for law of cosine. So if you just want to be in the habit. What side corresponds with my obtuse angle? C. So remember, you put what's missing in the top. So we're going to do side C in the top, and then sine of angle C in the bottom. And then we're going to use our known pair, which are the B's. Side B over sine of angle B. So C over sine, angle C is 107. And it will equal side B, which is 15, over sine of angle B, which is 25. So C is being divided by sine of 107. So we're going to multiply both sides by sine of 107. And we're going to round to the nearest tenth. All right, I got 33.9. What about you? So 33.9. So at this point, all we need to solve for is side A, right? Can I use the Pythagorean theorem on a non-right triangle? No. So I've seen a lot of people try. You're not going to get the right answer. You have to set up the law of sine again. Are we ready for side A? Beautiful. So again, you want what's missing in the top. So side A over sine of A. And then I would just use the same known pair from the beginning. Side B over sine of B, which was 15 over sine of 25. We don't know side A, but we do know the angle from A is 48. Then multiply both sides by sine of 48. So 15 over sine 25 times sine of 48. I got 26.4. What about you? 26.4. Beautiful. So again, the pattern should be the same. The biggest angle should be across from the biggest side. So biggest angle, biggest side, that checks out. Smallest angle should be across from the smallest side. If not, then you kind of know, like, either you labeled wrong or found wrong or something. Questions on this one? Okay. We're going to try the whiteboards. So we want to find AC. You can call it whatever you want. I'm going to call it B because it's across from angle B. You want to look for a known pair, which would be a side and an angle. You know both of. So I know angle A is 118, but I don't know side A. I know side C is 24. Angle C, I don't know yet, but I can find because I know two angles. I know 118 and 22. I can add them and subtract them from 180. So add them, subtract them from 180, we get 40. Because this makes 140, subtract that from 180, we get 40. So our known pair are the C's. We're going to find B. So remember, you put what you don't know in the top. So B over sine of 22. And it will equal side C, which is 24, over sine of angle C, which is 40. You just multiply multiply both sides by sine of 22. Just type it in as you see it. You get 14.
Miss Marshall.
All right, same thing over here. We want to find BC, which is across from angle A. So we're going to call this side A. We want to look for a known pair. We have 27. We don't know angle B, but again, we can find it because we know 51 plus 39 makes 90. Subtract that from 180, and that's 90. So this is a right triangle, but we're practicing law of sine. Remember that you can use the law of sine and cosine for any triangle. So we want to put what we don't know on the top, which is side A over sine of angle A. And then put side, so we know the B's. Side B, which is 27, over sine of angle B. And then multiply times, oops, sorry. I wrote sine of A and not the number. Angle A is 39 degrees. So sine of 39 on both sides. And then A equals 17. It's like 16.99 something something. So round up to 17. Find angle A. So the reason we use the law of sine is because we have a known pair. We know all three sides and we know an angle. A lot of people are like, which angle is this attached to? Well, this is obtuse, isn't it? So is angle C obtuse? Absolutely not. Angle B is obtuse, so it's attached to angle B. So we know the B's. We know 33 and angle B. We want to find angle A, which is across from 11. So we're going to do sine of angle A over side A, which is 11. Set it equal to sine of our known pair, so sine of 129 over 33. Multiply both sides by 11. Type it all into your calculator. Remember, you want to leave it in your calculator. Let your calculator do the hard work. So sine of 129 is in the numerator. 33 is in the denominator. Times 11. Leave it in your calculator. I'm going to write it down because I'm the teacher. You don't have to write down unless you want. But I would not round it. I would hit shift sign. Shift sign. Oops, I missed it. Shift sign. And then a previous answer. Oops. Answer. All right, we get 15 degrees. Then the last one we're going to do, find the measure of angle C. So we know 19 goes with that one. Now we want a known pair. So that would be 97 and 22. Always put what's missing in the top. So I'm going to put sine of C in the top over side C, which is 19. And it equals sine of 97 over 22 times 19. So we're going to type it in again. Sine of 97 in the numerator, 22 in the denominator, times 19. Remember, you don't have to write down the whole big decimal, but don't round it. Hit shift sign, a previous answer, and angle C is 59 degrees.